Here's an example of the Kruskal greedy algorithm for finding a minimal spanning tree for a weighted graph. This is number 12 from the book, 12 graph Q. There's a graph R also. We're going to save that one for the homework. So the first thing that I need to do is write down a list of all the edges and their lengths or weights so that I can choose from among them. Probably the easiest way to do this is just to start at vertex A and write down the edges. So I've got AB and AD. So I'd write those down, 8 and 10. Move over to vertex B. B has some other ones we haven't written down yet. I wouldn't write BA again because I don't need each edge twice. So BD, BE, BC. Then move over to C, and C has some new ones, CD, CF, CH, and CG. Then I'd move to vertex D, and the ones from D that we haven't written down yet would be DE and DH. Then we'll get EF and EH, and FG and FH, and then finally GH will be the last edge that I'll write down. And I could just make a list, as I've done in Excel here, of what the edges are and what their weights are. And we should probably take a moment to double count, make sure that we've got all the edges accounted for. I can either go through here and just count how many there are, or I could add up the degrees of all the vertices, get the total degree of the graph, and then divide by 2. Either way, we need to come up with 16 edges. Now for the greedy algorithm, the reason it's called greedy is that we're going to go through now and just pick the smallest edge to start with. Looks like we'll get this one. And just add the shortest weights we can find, making sure as we go that we don't get a cycle. And pretty soon we'll have a spanning tree that will have all the shortest lengths possible in it, so it will be minimal length or weight. So I could do that by hand. I could also use Excel to kind of speed up the process for me. I could copy these over here or just use the original list and sort them. If I go up to the Data tab and hit Sort and tell it to sort on column F, that's where the numbers are, and go from smallest to largest. Now I can just look down this list and really easily pick off the edges that I want to use. So I want FG first of all. So let's put that edge in. And edge BD, I'm going to add that one in. And so now when I start adding another edge, I just need to make sure I don't add a cycle. So EH, that one's going to be okay. Still don't have a cycle. Let's go to the next edge is FH. And that one's okay to add in. The next smallest length is AB. We haven't connected to vertex A yet, so that one's okay to add in. Next one on the list is EF. If I were to add edge EF here, I would have a cycle, this triangle. So I'm not going to add that in. And another way to look at this is that I've already arrived at vertex E and vertex F from somewhere. And so to add another way to get to E and F is extraneous. I don't need that. It's redundant, and cycles aren't going to help me. And plus, I wouldn't have a tree anymore. So we're not going to do that one. We'll skip over that edge. Now notice my next 3 edges here in the list all have the same length. So I kind of have an option here. I can add CF, or I could add CG, or I could add DE. And it doesn't really matter which one I do. It's just that I have a choice here, and there may end up being more than one minimal spanning tree. But any edge that I choose here is going to work. So let's just pick the next one in the list. Let's just pick CF and add that in. And we can kind of see here, if I had added CG, I would have also included vertex C, and then CF would be unnecessary. If I had included DE, then my next choice would have been to come over to either CF or CG, and again, one of those would be added. So either way, we're coming up with a good minimal tree here. So I'm going to skip CG. It would have made a cycle if I included it right now. And I don't want a cycle, so I wouldn't have a tree if I did that. DE is okay to add in. Notice I've got these two disconnected trees here, and when I put DE in, now they are connected together, so I've got just one tree here, and I've hit all the vertices, and so I'm done. So once I've added DE, I don't need to do anything else. If I had added DE first, back when we had the choice of all these 9 weighted edges, then I would have had the choice now of either CF or CG. So it looks like there's 2 different minimal spanning trees, one that has CF, one that has CG. But I've accomplished my task. All I have to do now is add up these values of the edges that I included, except not including the ones that I've skipped. So I need to add up the up through here, and then also that one and that one. And when I add those up, I get 51 as the length of the minimal spanning tree, and now I have accomplished my task.